Welcome to the Cloud Native Testing Podcast. I'm Ole Lensmar, your host, and I've spent years building testing tools like SoapUI and Swagger, and now I'm the CTO at TestCube, where we're redefining testing for the cloud native landscape. In this podcast, we invite people in the space to discuss with us the challenges, solutions, and best practices for testing in Kubernetes and beyond, covering automation, CI/CD, GitOps, and more. This podcast is proudly sponsored by TestCube. If you're interested about how to test cloud-native applications and infrastructure, subscribe and stay tuned. Now let's dive into the episode. Thank you for joining. Okay, great. Welcome again. I'm super happy to be joined by Tony Tam today, a person I've been very familiar with for, it's like 10, 15 years now, Tony, right? We ran into each other, was it, 2011, 12, maybe even earlier? Do you recall?
I do, but I try not to give away any hints of age.
Okay. Kindergarten, 2011, 2010, something around there.
Exactly.
Yeah, okay.
Yeah.
So before we kind of jump into the cloud native testing things I want to talk about, for those who don't know, Tony, the creator of Swagger, a technology that has had an enormous impact on, I think, how we still build APIs today. Tony, it'd be awesome to hear from you kind of a little bit on the background there and kind of your thoughts on, where Swagger is today, although it's now called something different. I think still that's kind of what most people know it by.
Sure. Yeah. So thanks for having me on, Ule. It's great to see you again. The background of Swagger. So I had been at a number of different companies and had some experience in the days of WSDL and SOAP. And one of the things I always liked about it was auto generation of clients. And later on in my career, when REST was taking off, I noticed that it was nice. Everyone really enjoyed being able to look at payloads in browsers and look at URLs that way. But the hard work of making clients was really a craft. So that you'd have like these artisanal REST clients that would be handcrafted and beautiful, and everyone liked them. But when things changed or when you were on a tight timeline, it was a tough thing to handle. And taking the good parts of WSDL, we came up with a way of describing APIs in JSON. After a few iterations, that became known as Swagger. I did not come up with a name, but it ended up being something that just kind of took off really organically. A lot of hard work from the folks that I was working with at the time. And I think we just were, fortunate in a great name, thanks to Zeke, and B, the timing of REST APIs just taking off. And thanks to that, we caught the attention of Ule and another group of folks that were trying to evangelize ways to standardize REST APIs. And that became a big movement. And a lot of companies supported moving Swagger into the Linux Foundation, renaming it as something not as interesting, but certainly neutral, OpenAPI. And a couple of different versions have come out since then. The last one that I was really leading was version 2, and then I was on the technical board for version 3. I hear there's a version 4 that slices bread and does all kinds of neat things. But the cool part about it was, yes, it solved my goal, which was auto-generating clients. We realized then it was really good at auto-generating documentation. Others started making it auto-generate servers. But the amazing thing, which is I think one of the main topic today, is that it really helped testing. And it helped testing by explaining what was there in the API, what it expected. And so you could certainly create tests for coverage, but it also would tell you what it was expecting, so you could do things that it was not expecting. So it says it wants a number. Well, you send in a character. It says it should be greater than 0, so you send in -1. So that really helped the testing teams a lot. And so now what I've been seeing, not to jump too far ahead, is that testing teams, when they're working really isolated from the developers, will just ask if they have an OpenAPI spec for the service, and then they'll start from that. Long-winded answer, but
lines up.
No,
thank you. it's a great answer. I think what really is interesting is when you talk to people about Swagger, it's different things for different people, right? To your point, some people think of it as a documentation tool or as a code generation tool, or as you said, as a testing tool. A lot of people that we've encountered say, "Oh, we use Swagger to test our APIs," right? So which is I guess you really found a way to build something that catered to a lot of different use cases, which is amazing. And but I also think you're really good at building a community around Swagger and all the tools around it, something that can often be hard for open source projects, which is
I mean, the community piece is just flat out stupid diligence and hard work, right? I mean, when I would get frustrated with my day job, this is kind of embarrassing, but I would work on Swagger because I believed in it and I thought it was fun. And I got feedback from people all over the place. One time early on, someone showed up in our IRC chat room and just said, "Hey, just want everyone to know we just deployed Swagger across like 300 servers and we ran $2 billion worth of financial transactions through it last year. Have a great day." And I didn't even get to know, like, I didn't even hear what on earth, what company it could have been, some adult site. I don't even know, but it was just kind of nice to see that people had picked it up and were doing useful things with it, not just, making pretty pictures.
No, and they were, like, to your point, they were sharing that you're using it. And you mentioned earlier, it evolved very organically. A lot of people chipped in on the code generation, on the different pieces of it. So it was not really seen as a one or two man's kind of thing, or it was really community effort, which I also think helped spread the words as much as it did and made it as ubiquitous as it still is. I mean, other things of when it comes into the world of APIs, obviously GraphQL has been big and is for good reason still being used, and there are other API technologies. But to me, it seems like REST APIs are still holding, are still going strong. What's your take on Swagger and REST in general? And don't want to turn this into much of a API technology discussion, but it's an easy topic for us to talk about.
I do think that REST will be here for decades to come. Asynchronous APIs are really, really useful for large companies and also different patterns of sending information, broadcasts, that sort of thing. GraphQL, I know that there's a fair amount of energy behind it. In the use cases that I've seen, it has been not fantastic. I think that the more interesting things have been socket-based full duplex transports. And there still needs to be good ways to describe those. And I've seen people bend OpenAPI into that to describe the payloads. And there's probably better ways too. And at some point I'll see them.
Yeah. Okay, great. So thanks for that. And it's really fantastic to have you here and obviously amazing what you spearheaded with Swagger. So what are you up to nowadays?
I'm working at a larger company that I'm running developer tools. So still in the space of making things to help people write great software. Certainly exposed to a lot of REST APIs as well. And sometimes I scratch my head and just think, like, I can't believe I'm still doing this like 15 years later. Surprisingly, and again, this conversation is not about OpenAPI and Swagger, but I still find lots of developers coming and saying, "I just found out about this thing." And part of me just wants to say, what cave have you been living in for the last decade or two? But it's also true that, there's a lot of different parts of software, and sometimes you don't have to worry about connectivity. You don't have to worry about this kind of communication. And once it becomes part of your job, you start hunting around and it's there are a lot of different solutions to figuring that out. And when people find OpenAPI, they're generally pretty happy until they look at the code generators, because there's a lot of garbage ones out there. I'm partially to blame for it.
Well, but I mean, even today, in the APIs used for interacting with OpenAI and others are I'm guessing described with an OpenAPI definition, and REST APIs are, I mean, as important as now as they were before. So people who are discovering this now, it just kind of shows that connecting systems using kind of a REST-based protocol is a very easy, straightforward way to do it, and very efficient. Works for like a lot of use cases. So I'm not surprised that continues showing up.
Yeah. And also just think of I don't know if you're a Star Wars fan, but when R2D2 can just like kind of plug into some computer and just start communicating with it. I mean, do you think that he is like packet sniffing to figure out the communication protocol? There's no way. I mean, he's got OpenAPI version 12
Uh,
or whatever it is, or
Definitely,
something like that. So
definitely something like
we
that.
can see it in the future. Watch
Yeah.
Star Wars, everyone.
Yes. But so segueing a little more over to like cloud native testing, the topic for the podcast. So I'm curious to kind of see, so you're leading developer tools for a large company, and I'm wondering kind of just testing in general, how much focus is on testing when you're working on internal developer tooling, maybe around standardization or best practices, and when it comes to both what tools to use and how to test or when to test, and how much is that something that can be kind of, is a top-down approach at a large company, or is it something that you more rely on, the individual developers in your organization to adopt in a consistent way?
Sure. So first off, just so that I don't get in trouble, I do developer tools for part of a large company, not all of
Okay.
the developer tools for a large company. I don't want to get in trouble for anything. So testing and cloud native and just general software lifecycle are really a fascinating topic. So I have this belief that good engineers really like writing good software. No one feels bad when they write all these tests and they click a button to deploy their software and they just are 100% confident it's going to work. Like, it's the best feeling in the world.
Mm.
And when projects are started in almost any scale, and you have good engineers on it, and they do test driven development or spec driven development, or there's probably cooler names now. A lot of them start that way and build software in such a way that it's tested, they're confident about it, and that sort of thing. What you see at big companies is, and I think that this probably applies to any big company in the world, right? People come and go, projects grow stale, they lose owners, people shift to different things, and new people will come on board and not really know what the intent was of the testing strategy, or maybe they've introduced a dependent service that is really complicated and they don't have time to mock it. And before you know it, the beautiful testing strategy that smart set of engineers set up is like out the window because of deadlines or whatever. And this is just life, right? It's hard to always stay on top of it. And then, somebody will say, like, there's a new version of JUnit. Let's update to that. And there's some old tests. So let's just, they don't run with the new JUnit. And I don't have time to rewrite them. So let's just disable them. Before you know it, you're in this like spaghetti ball of software. And I think that without things like containerization, without ways of isolating your service and how it talks to other things and mocks and that sort, you're kind of stuck. And then the ball gets bigger because you need more time to test because the testing has gotten behind. And before you know it, you're moving like a slow big company, not like the one I work for, of course. But there's a problem, I think, in testing in general that needs better structure. And I don't think it's just top down. I mean, you can't just say, look, write tests, right? You need to have infrastructure and tools that make it easy, that make it, painless. And if you disable a bunch of tests, that, red lights, alarm bells, like whatever, like you don't just forget the fact that you disabled these tests and that becomes like your new test set. So I think that there's like a whole suite of infrastructure that every company needs, especially big companies, in order to keep from going down that path that I was describing.
I mean, recently over the last year or two, there's been a lot of talk about platform engineering, especially in the Kubernetes world. And it feels to me like that it falls a little bit on the platform engineering team to put those testing and quality guardrails into place to make sure that it's easy for developers to, add new tests, and that all the tests that are there are kind of in line with whatever framework, that one might have standardized on, which also makes it be maybe easier to adopt existing tests. Do you see anything like that happening on your end? Like, as a platform engineering teams are responsible for testing being in place, maybe not for writing the tests, but responsible for that there are quality gates and that sorts that are in place?
Sure. So there definitely is this platform level tool infrastructure, test structure, that sort of thing, that if you put it in place early, it's pretty easy. I mean,
Mm-hmm.
it's sometimes it's easier than winging together your own suite and setting it up in your CI and that sort of thing. If you put it in late, it's a nightmare.
Mm-hmm.
It can be a nightmare. If it's something that's not part of is like maintaining that is not part of the normal SDLC, then you still end up in that problem, right? It's
Mm-hmm.
stuff that it requires maintenance. Things change, right? Like there's new tools, there's new languages, there's new communication protocols, there's MTLS, there's all this stuff that just needs constant tending to.
Mm-hmm.
But when it's done right, I mean, you get velocity, right? And you're not running into walls. So
Mm-hmm.
I do see that. I
Mm-hmm.
do see that. I think it's critical, and I think it's critical to start it early on.
Do definitely agree. I think on one of the other guests we've had, we talked a lot about this, that it's a lot about culture and communication, and to your point, starting early on and having just an awareness of testing, which I think everyone has, in the sense that where they know it's important to test, but then, like you said earlier, other things get in the way, and it doesn't always play out that way. But maybe you really need someone in your team or org that is the lead voice for testing and QA, however boring that might feel at the time. It's usually important in the end. So when it comes to cloud native specifically, do you feel like that a shift to Kubernetes and containers and all these things has made testing, has changed testing, or made it easier or harder? Or is it been easier maybe to keep up with testing thanks to that your system is broken down into smaller components and they're easier tested on their own? Or has it been harder because it's harder to do thorough integration tests or mock out external dependencies?
I mean, there's so many parts to that. I think that yes, containerization and running services in isolation with clear boundaries and clear points of isolation is amazing. You're not having to set up an operating system and install these dependencies and all that sort of thing, right? Like that is incredible. Just the nature of containerization and having service dependencies in other pods and that sort of thing creates new kinds of things for you to test. Network connectivity is like routing rules and namespace isolation and that sort of thing. It's a lot easier to test when you can spin up a whole environment. Making one that mimics production is hard, especially when your company gets big and you have many data centers, or maybe they're different regions, or maybe there's complete different infrastructure because of export compliance and that sort of thing.
Mm-hmm.
But I think in general, the right structure for cloud native testing is essential, right? And it's also not easy, meaning that like you need somebody else's expertise in it. Like the full stack engineer ends at cloud native testing infrastructure, I think.
I mean, something we've seen a lot of our users is the need for like infrastructure testing, which I think wasn't something I was very attuned to before. But so basically when teams provision, if they dynamically provision clusters or environments which contain a bunch of baseline components or maybe even hardware that they need for, AI or whatever, then that they actually want to run tests just to validate that application infrastructure is in place. That's not something that usually historically that's something that I felt it's just there and you don't really test for it. But now maybe that the fact, since it's so easy to dynamically provision infrastructure or application infrastructures, there's also suddenly a need to test that provisioning is successful or not. Is that something that you can relate to or have encountered?
Yeah, I mean, think of like getting into the GPUs, right? There's different versions, there's different worlds of that. Like there's different hardware that your application might think that it has, and for all you know, somebody like inventoried some server in the system and you get the wrong thing, right? Virtualization is great, but it doesn't isolate you from everything, right? At some point there's a computer running your software, and that computer could have problems. I mean, if you look at I know that hard disks are not super interesting now, but if you look at like any of these large storage vendors, the rate at which disk drives fail is like insane, right? Like they'll be going through like 100,000 hard drives a month. And so like, yes, like the network, I mean, you could have a flaky router that you're connected to, right? That's a physical port is bad on the router that your server is connected to, that you're virtualized over, but you're not going to really feel it the same way. You can say, why is my software running kind of flaky? But under the hood, there could be a piece of infrastructure that's giving you grief. Yes, I think at some level you need to actually do some tests against that. Like we've seen things you wouldn't believe as far as hardware, right?
Okay. Well,
Not to sound like Blade Runner, right? But like, it's true.
But does that also mean that as you build your applications, do you have to build maybe a new type of resilience into them? Or I was thinking like, or do you have to test not just the infrastructure, but also do like chaos testing to make sure that your application can handle, a flaky infrastructure, to your point? It's not, is that something, I mean, I guess it's a question of scale. Where would you draw that line? Any thoughts on that?
Yeah, I mean, I think that this part of it is like just plain service. Well, you could call it microservice testing, but like dependency handling issues in dependent services, no matter where they are, like in your infrastructure or external, like ChatGPT, is just hard, right? You don't have any control over how often, you don't have any control over their reliability, how they update changes that they put forth. Like what used to be a certain error code changes one day because some engineer says, I need to make this better. And so I think that whole dependency graph of software, think of it as like the once you're calling other people's services, like your dependency manager is gone, right? Like, and we all know what life was like when you had to like copy jar files from the internet into your build, right? You just never really know what you're going to get. And so that sort of thing in building resilient software, there's things that can be done from like the connective clients, but even with that, it's just hard. And how you handle it. I mean, can you use a cached response if a service is down? Well, it depends. What is it? If it's a credit card transaction, the answer is no. If it's like looking up something in a dictionary API, the answer is probably. If it's a login token validating a user authentication session, I mean, maybe. It depends, right?
So maybe that's something you have to think of when you design your APIs and both your clients and your servers to be fault tolerant from that point of view.
And I think that like, back to good software, like a good software engineer who's good at service architecture is going to understand when that function they're calling is doing something expensive or calling some other service, and really depending on the response versus loading an emoji or something like that like might not matter as much, right? That stuff is just hard. And I know that there are some pretty neat tools in the cloud native world to understand the traffic and to get a sense of what you're doing actually in production, that I think is super useful. I'll be honest, I'm not totally familiar with all those tools. We work with our SRE teams to understand that better, but I know that's a whole world that is extremely important for any of these applications. Your app is calling ChatGPT. You're not making your own ChatGPT. So like everybody's using these things much more in a much more dependent manner, right?
Well, maybe that's kind of some of the traits that are specific to cloud native testing versus monolithic testing, or I don't know what we want to call a pre-cloud native, is really to make sure that resilience both and reliance on infrastructure, and test that both your infrastructure, do chaos testing, or kind of make sure that you can handle flaky networks, flaky components, etc. if your applications are distributed. So as a QA or as a team trying to design test strategies for something in production, maybe those are things to weigh in that you wouldn't have had to do in a non-cloud native world.
Definitely. And I think that you personally have experience in your previous life, that sort of thing, right? But it's probably made much easier with cloud native technologies, but absolutely.
Yeah, I mean, like you've said, I think before, is, building good software is hard and there's a lot of complexity. I think we're adding complexity with cloud native, but also obviously it gives us also possibilities and advantages like everything. And I think as for testers in QA, that's just something to be aware of and learning. If you enter the world of cloud native testing, if you're coming more from I don't know, what is non-cloud native world?
OG testing. Yeah.
OG testing. Yeah. Okay, great. Tony, this was amazing. It's so great to catch up with you, and still once again, an honor to have you on the show, and good luck with all future endeavors, testing or not, APIs or not. Thank you.
Yeah. Thanks a lot.
Okay. Take care.